Pluto's process through space forces it to rise and fall in its circle as it converges with the ways of other divine bodies. Outstandingly when it crosses the direction of Neptune in the farthest locale of our nearby planet group. Pluto, the fascinating and strange bantam planet, is blending impressive interest in the domain of space science. New discoveries show that Pluto may be on a potential impact course with Neptune, which is causing extensive tension among cosmologists and space devotees the same. Notable figures like Neil deGrasse Tyson and Mito Kaku have raised concerns about the conceivable result of such a vast event. Yet, what has driven Pluto to this possible crash with its adjoining planet? Furthermore, what effect could such a divine accident have on Earth? Gone along as we dive into how Pluto's way crosses Neptune's and why this orbital oddity is agitating the logical community. At first named a planet, Pluto was subsequently reimagined as a bantam planet because of its unpredictable circle. Anyway, in spite of this renaming, Pluto still charms the minds of stargazers and space enthusiasts the same. As of late, specialists such as Neil deGrasse Tyson and Mito Kaku have voiced concerns over Pluto's orbital way, which could bring it perilously near Neptune. This nearby arrangement suggests that these two giant divine bodies could collaborate in ways that could have significant ramifications for Earth. Pluto's circle is not normal for that of other planets in our planetary group, prolonged and flighty. Since its discovery in 1930, Pluto has not finished a single full circle around the Sun, which only adds to its charm. Not unlike the more round circles of the planets, Pluto's curved way stands apart as a characterizing normal for our nearby planet group structure. Another enamoring highlight is the slant of Pluto's circle, around 17 degrees from the plane of the ecliptic, which is more keen than that of any of the fundamental planets. This mix of a slanted and extended circle adds layers of intricacy to Pluto's movement around the Sun. One especially interesting perspective of Pluto's way is its intermittent communication with Neptune's circle. For approximately 20 years in each cycle, Pluto's circle carries it nearer to the Sun than Neptune's, an event that opposes assumptions because of the two planets' generally unmistakable positions. Eminently, Pluto's circle isn't roundabout, but shaped more like an oval, which causes huge changes in its distance from the Sun. At its closest point, Pluto is around 30 cosmic units, AU, away from the Sun, but at its farthest, it loosens up to in excess of 49 Australian dollars, double Neptune's distance. Pluto's circle is likewise shifted at a key point comparative with the circles of other significant planets, further confounding its developments and connections, especially with Neptune. When Pluto and Neptune adjust in their circles, their gravitational powers modify each other's ways. This many-sided relationship highlights the interconnected nature of heavenly bodies, with every one applying gravitational impact that shapes the other's directions. Lately, headways in observational innovation have permitted stargazers to follow Pluto's development with noteworthy precision, offering a more profound comprehension of its orbital mechanics and the possible impacts on the dependability of the external planetary group. Albeit a direct crash among Pluto and Neptune stays impossible, the chance still exists, powering expanded interest and concern among stargazers. In spite of its minor size and far-off area, Pluto keeps on catching the attention of specialists and the public the same. So why hasn't Pluto crashed into Neptune? The critical lies in the gravitational communications between the two bodies. When stargazers originally concentrated on Pluto's circle, they were astounded by its flighty conduct. Not at all like most planets that stay inside a reliable plane of circle, the ecliptic, Pluto's circle goes astray pointedly, adding one more layer of secret. The genuine puzzle came when researchers understood that Pluto's circle meets Neptune's. However, regardless of this strange crossover, Pluto's circle stays stable. This peculiarity addresses the unpredictable mechanics of space and the trouble of anticipating divine ways. Understanding the gravitational transaction between Pluto, Neptune, and the Sun presents a critical test for researchers. Foreseeing these communications is likened to deciding future positions in view of introductory circumstances and gravitational powers. For Pluto, the association between its circle, Neptune's circle, and the Sun's gravitational force creates a fragile framework that keeps its way steady. Terms like precession, libration, and VSOP varieties assist stargazers with understanding these perplexing elements. These ideas are imperative for ensuring the strength of planetary circles. When Pluto crosses Neptune's circle, it is still around 90 degrees away from Neptune, which forestalls any direct impacts. The course of libration guarantees that Pluto stays securely on its circle even as it approaches Neptune. VSOP varieties, named after specialists like von Zeipel and Pacer, make sense of why Pluto's circle could appear unpredictable but stays unsurprising over time. Despite the fact that the universe might appear turbulent, the powers at work tend to stabilize planetary circles, decreasing the probability of impact between Pluto and Neptune. This fragile equilibrium highlights the awareness of divine circles to their beginning positions. Even little changes in a planet's speed or position can cause huge changes over the long haul. Through cutting-edge computational reenactments, space experts have demonstrated Pluto's orbital development, seeing how minute varieties in factors can decisively change its direction. In the late 20th century, these reproductions uncovered that while Pluto's circle may seem steady, it can in any case be dependent upon tumultuous vacillations. Even minuscule contrasts in Pluto's beginning position or speed can prompt striking changes over the long run. Anyway, Pluto's circle has stayed stable for billions of years, recommending that notwithstanding its obvious inconsistencies, it follows a recognizable design. Anticipating the behavior of planets with such unusual circles is still a troublesome errand, with the systems being unusual to the point that long-term predicting is challenging. Reenactments are helpful for assessing conceivable results, but they also exhibit the inherent unusualness of divine developments. Understanding Pluto's circle is urgent, especially while considering the slim chance of an impact with Neptune in the future. Gaining deeper knowledge of these developments assists us with grasping the inward functions of our nearby planet group and illustrates how even seemingly unsound circles can be stabilized through gravitational powers. It uncovers the ways that the positioning and movements of planets can influence the ways of other objects in space. In spite of space's intricacies, the chance of Pluto crashing into Neptune continues to concern cosmologists. This present circumstance asks the question, how should such an impact happen? Despite the fact that it appears improbable, Neil deGrasse Tyson, a prominent astrophysicist, has commented on Pluto's renaming as a bantam planet. He considers it to be a significant forward-moving step in how we understand the universe, reflecting how we continue to learn more about the movements of divine bodies. Tyson believes that events like Pluto's renaming connect with the public in the quest for space science and stress how much remains to be discovered. Tyson, alongside other scientists, has raised alarms about the potential dangers of Pluto's circle, especially the risk of a crash with Neptune. He suggests that such an effect would be a grand event for our nearby planet group, causing far-reaching influences throughout the universe. A Pluto-Neptune impact could release huge amounts of energy, potentially breaking Pluto and sending debris into space, perhaps slamming into other divine bodies. Indeed, even Neptune's circle would be disturbed by such an event. Mido Kaku, a notable theoretical physicist, offers his insights into the heavenly mechanics at play. Kaku emphasizes that research on Pluto's circle is critical to understanding the fate of space exploration. He believes that by grasping the gravitational interactions between bodies like Pluto, we can improve future missions and explore space more safely, limiting potential risks. His work in string theory, a way to understand the major laws of nature, could also uncover more about the forces shaping the universe. Kaku believes that studying Pluto's elements can open further insights into the forces that govern reality itself. Both Tyson and Kaku agree that observing a potential Pluto-Neptune impact offers a unique opportunity to advance our understanding of the universe. Specifically, such an event could provide valuable information for string theory, which models the universe as a series of vibrating strings. Although the immediate effects of a Pluto-Neptune impact on Earth would be unimportant due to the vast distance, the scientific benefits would be broad, improving our understanding of theoretical physics and the nature of the universe. As researchers continue to study the gravitational impacts applied by neighboring planets like Neptune, the ever-changing nature of space becomes increasingly clear. Anyway, space remains full of mysteries. The three-body problem, where multiple heavenly bodies apply gravitational forces on one another, is just one of the many challenges astronomers are trying to solve. Ongoing exploration of space is essential for expanding our knowledge of the universe and the laws that govern it. While the likelihood of planetary impacts is very low, the probability persists due to the impact of gravitational forces. These forces can subtly change the circles of planets, potentially leading to crashes over time. One example of this phenomenon is the TRAPPIST-1 system, which contains 7 Earth-sized planets. The gravitational interactions between these planets can create orbital resonances, potentially threatening their orbits and leading to future impacts. Scientists are closely observing these systems to better understand how heavenly bodies interact and how their ways can change. In addition to planetary associations, rogue planets, divine bodies that no longer orbit a star, can float through interstellar space. These planets, once part of a nearby planet group, can travel great distances and sporadically crash into other star systems. However, the immense void of space reduces the probability of direct crashes between rogue planets and other heavenly bodies. At last, when galaxies impact, the huge gravitational forces involved can upset the orbits of stars and planets. While planets may not directly impact each other, their orbits can be altered, potentially hurling them into space or causing them to crash into other planets or their host stars. Such unsettling influences can lead to the creation of new heavenly bodies or even new stars. The late heavy bombardment hypothesis suggests that around 4 billion years ago, a surge of impacts from comets and asteroids occurred, potentially caused by the movements of external planets like Jupiter and Saturn. These impacts reshaped the orbits of smaller objects in space, many of which were shot out into the inner solar system, where they crashed into Earth and other inner planets. However, these impacts didn't involve direct planetary collisions. They played a critical role in shaping the surfaces and structures of planets, particularly Earth. The fact that these crashes contributed to the delivery of essential elements like water and organic molecules to our planet, creating the conditions required for life, serves as a strong reminder of how gravitational forces from larger bodies can significantly adjust the orbits and paths of smaller divine bodies. Taking everything into account, similarly, Pluto's unconventional orbit raises questions about a future crash with Neptune. The historical effects of cosmic forces help remind us of the dynamic and evolving nature of space. The delicate balance of gravitational forces governing planetary systems remains a focal point of research, helping us understand how our nearby planet group and the universe at large have evolved and will continue to evolve over time. The potential for future encounters, whether between Pluto and Neptune or through other vast phenomena, highlights the complex associations that drive the ever-changing nature of space. Pluto's bizarre orbital way around the Sun fills in as a perfect representation of space's idiosyncrasies. Not at all like different planets, Pluto's circle isn't entirely round. At times, it ventures nearer to the Sun than Neptune does, adding to the interest of its grandiose dance. However, the opportunity of a crash between Pluto and Neptune is small. It is essential to recognize the strong forces at play in shaping their circles. Gravity, the invisible apparent power that governs the development of heavenly bodies, ensures that Pluto and Neptune stay in their designated ways, notwithstanding their obvious potential for impact. The investigation of Pluto's circle offers significant bits of knowledge into the forces that govern space. What could at first appear tumultuous is often the consequence of finely tuned gravitational collaborations. Constant examination and observation are significant for growing our understanding of the nearby planet group and beyond. The thought of a Pluto-Neptune collision raises entrancing inquiries about the likely changes to our understanding of the external nearby planet group. Despite the fact that we have gained extensive headway in space exploration, such an occasion would highlight how much we still need to learn, signaling the requirement for additional research. By exploring how larger planets impact Pluto's circle, cosmologists are opening significant data about the behavior of the entire planetary group.